In this project, we are going to simulate the rotation of a cube considering the sloshing simulation.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by MR-CFD. Or if you are watching the training video, click on the MR-CFD logo and subscribe.
Next, right-click on Mesh and then go over Import Mesh File. Then click on Browse and then select the mesh file that is sent to you with the rest of the files. Now there are several assumptions taken into account for this project. First, the type of our solver is set to be pressure-based since we are dealing with incompressible flows. Second, we have selected the absolute format for velocity formulation. And third, we have selected transient time study since we are dealing with a time progressing phenomenon. Also, you can see here that we have enabled the gravity and its value is equal to minus 9.81 in y direction. After double-clicking on the viscose button, a new window will appear. In the appeared window, you will see that we have chosen two equations, standard K epsilon, to solve for our fluid flow. The standard K epsilon model is one of the most renowned models for solving the turbulent fluid flows, and actually two equation K epsilon model allows the determination of both a turbulent length scale and time scale by solving two separate transport equations. As was mentioned in the previous slide, in order to add a new material, all you have to do is to expand the materials, go over Fluid, right-click on it, and then select New. After double-clicking on the Controls button, in the middle section of the software window, you can see that new part will appear. In the Appear part, you can see under Relaxation Factors for different parameters. Now, these values are set here by the software automatically. You can change these values, which are between 0 and 1, by yourself for different projects you do. But it is highly recommended that you do not do that since it may result in divergence. In this window, under the phase section, change it from mixture to air, and under the variable section, select volume fraction. Under the value, then, you can see that we have entered the value of 0 for the volume fraction of air, and then under the registers to patch, we have selected the water region. Now, by patching this change into our model, the software will automatically set the volume fraction of air in that region equal to 0, while it sets the value of volume fraction of water equal to 1. Now, in this window, you can enter the input coordinates for the starting point of your region to its ending point. Now, since we had previously created that region, we simply click on Cell Registers, go over Manage, but you have to click on New and then select Region. In the appeared window, under the surface of constant, select Mesh, and then underneath it, select Z coordinate, and then click on Create button. In the appeared window, under the Contours of section, you can select your desired variable. For example, in this slide, you can see that we have selected the pressure variable. And under the Surfaces section, select the Z coordinate surface, which you created in the previous slide, and then click on Save or Display button. Now in this slide you can see the pressure distribution inside our computational domain. Also you can see the hydrodynamic pressure due to the existence of a column of water in our model. Now in this slide you can see the volume fraction contours of water. Also you can see the changes in the level of water due to the rotation of our container. Finally, a summary of the settings and setup that we have used in our project is presented in this slide.
Obtain the mesh file and also the full training movie by purchasing this product.
To benefit from MR-CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.